All right, so last Friday we had a mammoth lesson, right? Today, today's lesson is going to be a lot easier. A lot of it's going to be familiar. Yes, Jason? Yes. Try to keep it all together in the folder if you can. Yeah, try to keep it in the folder if you can. Yeah. Look, basically, you can have loose sheets, but try to keep that to a minimum. Yeah. Okay? So, yourselves, if you could listen now, please. Have a look at what I want you to be able to do today. So, interpret the slope and interpret the intercept. If you were in year 11 last year, that should sound familiar, even though most of you didn't do it on the exam. We did cover it last year. Interpolation and extrapolation, we also did that last year as well. All right? Flashback. Okay? There's only one thing that's new today, and that's looking at the residual plots. All right? But I'm going to go through all of this with you now. Okay? So basically, there's only one piece of new content today, and after that, you're ready to do sort of analysis using linear regression. Yep, I'll do a brief review. Okay, so if you forgot everything from last Friday, which is understandable, we forget things. The reason why we need to practice is to store things in our long-term memory, and then it's less taxing on us to do stuff. So, I've got some data. Those are the x's on the scatter plot. And I want to fit this line y equals a plus bx to the data to model it. So a is the intercept. That's a term we're going to use today. And b is the slope. And last lesson, we spent a lot of time answering the question of how exactly we choose these values a and b. All right, so we choose a and b, long story short, by minimizing the sum of the square of the residuals. I'll go over residuals later because there's an example related to that, but you want to know that sentence? And you get these formulas, which are given on your formula sheet. And most of the time, you don't use those formulas. You just use your CAS. Okay, that was last lesson in a minute. We spent a lot of time discussing what a residual was, so I'll just remind you very quickly. The residual value. So just always think of these as vertical lines joining the point to the regression line. It's the actual value minus the predicted value. So the actual value is the dot. The predicted value is on the line. Okay. That's all I'm going to say as far as last Friday goes, all right? Okay. So, on the left, so I'm going to do 4 questions on the work program now. On the left is going to be the theory, and on the right is going to be a question to tick off. Okay, so you don't need to do the questions again. So, when you do your regression analysis, you will get an equation of this form. Y equals A plus BX. A and B are going to be some numbers. So remember, this is the, not the slope, this is the intercept, and B is the slope. Now that we have actually found A and B, now we want to do some work as statisticians to say, okay, what do these numbers mean? So now that I've done the calculation, I've put it into the cast, some numbers have come out, what can I actually say about the data? So you may want to write this down. So the slope tells us, on average, does anyone remember the sentence from last year? It's just the gradient. So what does the gradient tell you? Excellent. Every increase in x by 1, y increases by b. And just note, if b is negative, y decreases rather than increasing. This will become more concrete once we apply it to an actual example. Okay, so that's the slope. What about the intercept? So guys, I don't quite know how to get this across to you, but I'm just going to try. This line that we fit to the data is just a model. It's just a prediction. So it might not be very good, but it makes a prediction from y every single value of x. Where is the intercept on this graph? Where the line intersects with the y axis. Yeah. Right. So that's the intercept here. So it's making a prediction for y when x equals what value? 0. Good. When x equals 0, you have the y-intercept. So the intercept term is here. So it's just telling us what this line is predicting when x equals 0. So I think I'll say the linear model predicts that when x equals 0, y equals a. I recognize this is going to feel a little bit abstract because there's no words or variables like real stuff. So let's actually do this with a real thing now, and I think you'll feel more comfortable about it. But I just wanted to show you the structure of the sentence you might want to write. When you do past exams, you'll see that to death because they ask this basically every year. Okay, so this is question 2 from the exercise that you're about to do. So I'll help you. I'll even help you out here. So if you haven't already memorized y equals a plus bx, now's a good time to do so. Which one's the intercept here? Yes, and can I have a number? 2.9. Okay. All right, so it's 2.9. So whenever you get an equation like this today, you're assuming that this equation has arisen from some analysis using linear regression. Okay. Also notice that they haven't written y and x; they've written them in words, and that's the form that, again, I'm not really sure why VCAR does this, because in the real world we don't do this, but for whatever reason, VCAR has chosen to write their equations using words, both in the exam and in the study design. So I guess it makes it easier. It just, yeah, I don't know. I've never seen it outside VCE. So, all right, so the intercept's 2.9. So what is it actually saying in terms of the relationship between handstand and height? Okay. So this is an exam question. Interpret the intercepts. So this would be worth 1 mark. All right, and you either know the sentence or you understand it well enough to reproduce the sentence, or you don't. So what are you going to write? On average, when which variable is 0? On average, sorry, can you speak up, Kai? Great. Now, let's make sure that we use the actual response and explanatory variable names here. So which one's the x variable? When height is 0, hand span is 2.9. Is that okay? So even though I've written x and y here, you want to drop in the words from the equation. Okay. When I marked the year 11 exams last year, most people left this blank. So that suggests to me that I didn't teach it very well last year. So if you're feeling a bit lost, because I do find that linear equations challenges most students given general maths, you can remember these sentences, and then you just need to find the relevant numbers to drop into the sentence. That's your starting point. And then once you understand that 0.33 is like the number multiplying height, that's your slope. And it's telling you how much it's changing. All right, so I'll do this one for you because I want to keep things moving. So the slope is obviously the number in front of the x variable. So the linear model predicts that on average, for every increase in height by 1 hand span, please complete this sentence for me. Is it going to go up or down? Right, the slope is positive, so it's going to increase. So please don't tell me it's going to increase if the slope is negative. It's going to increase by how much? 0.33. All right, I'm just going to take a quick poll of the class. Yes, I can move on. I need more practice. I'm going to vomit. Okay, thank you. We'll keep moving. All right. Have you come across this term in any of your science subjects, like psychology, physics, chemistry? Psychology employs the scientific method, Anthony. It's just very difficult to control all the variables, like impossible. Okay, so have a look here. Um, these could be results from experiments. My background is science, so I often present experiments, but it could be any data that you've collected. Normally, you only collect data within a range. So once I've got my data, I can get a model, such as a linear model. That's the only model we have right now. And we can use that model to make predictions. So for example, I could predict that when x is over here, I'll have some particular y value. I can predict over here. And I can also predict in between the existing values in my data set. We use the terms interpolation and extrapolation to distinguish between whether the prediction is within the range of the data and whether it's outside the range. So if you're within the range, it's interpolation. And if you are outside the range, it's extrapolation. Is that all right? So you can probably see where this is going. Generally, when you talk to a statistician, they will consider one of these to be more reliable and one of these to be less reliable. So if you were to decide between which ones you would trust more for predictions using the line, would you be more inclined to trust a prediction within the data range or outside the data range? Within the data range. And why is that, Kai?
Because if it's outside the data range, you don't have any existing points roughly where that one should be. So yeah. Best guess on where the data is already.
That's right. And things can change outside the data range. Like you might think it's linear, and then you might get non-linear behavior later, which you'll see in physics. Right? So we generally regard, so I'll write this down. We regard interpolation as more reliable than extrapolation for the reasons that Kai mentioned just now. As soon as you go outside the data range, you got the data anymore to support your claim, and things can change. Economic forecasting is all about predicting the future, right? That's extrapolation. You don't have the data from the future yet. Weather forecasting, you're predicting the future. You don't know what the weather's going to be like tomorrow, but you're going to make a prediction. Sometimes they get it right, and occasionally they get it wrong. We notice when the weather forecast is wrong, but a lot of the time they get it right. So, what do you need to do? You need to know these two terms. So I could ask you, is this prediction an example of interpolation or extrapolation? And I might ask you to comment on whether one prediction is more reliable than the other. So you need to know this sentence. Okay? All right, so let's do a quick example. This is question 4. So I'll just draw your attention to the key information. We've got a relationship between height and age. And we are assuming that the data has been collected where age is between 36 and 60 months. So I want to do two things. Number one, I want to make a prediction. And number two, I want to decide whether that prediction is an example of interpolation or extrapolation. So let's start with age equals 20. Is this value 20 within the range 36 to 60? Nope. So 20 is outside the range. So it is extrapolation. All right, what about 50? Is 50 inside the range? Yes, it is. Okay, so that's interpolation. I'll just do the prediction for this one. So how can I use this equation to predict the height when age is 50? It's a simple calculation, which, again, my year 12 had trouble with last year because they didn't understand that this line is used to make the prediction. Keep going, Anthony. What do you want to do? So you're going to change this to 50. That's it. Okay. So you're going to substitute age equals 50 into the equation. So height equals 72 plus 0.4 times the age that I want. So the age this time is 50. Okay, and you should get 92 if you do that calculation. You guys okay? You're very quiet. When my class is quiet, I get very, very worried. Yeah, but that'll it's, but like you're quieter than usual. It's yeah. Yeah. I mean it's easier to teach, but sometimes I think that when the class is quiet, I'm teaching nobody. Like you're all just sitting there like yeah. Okay. All right. Still got 3 more pages to go. All right. Are you guys okay with this? All right. I think I will go over this again next lesson because you need it for the SAC. Oh, it just keeps going. All right. I'm sorry about this, guys, but yeah, as you can tell, VCE is quite demanding. All right, so this is actually just revision from last Friday, but there are a few questions that asked you to calculate the residual. So I wanted to go over this today anyway, so it's good that we've got a question to do this with. So we've got another regression equation. So we've got some data, we turned it into y equals a plus bx. So part 1, make a prediction. Anthony just gave us an example of how to do that. We take the value that's given and substitute it into the equation. So here the weight is going to take on the value 980, and then I'll calculate the value for fuel consumption. So in this case, fuel consumption equals negative 0.1 plus 0.01 times 980. And if you do that, you get 9.7. Okay, just use a calculator if you don't know the trick with the decimal point. Say that again. Yeah, but I'm plussing 9.8 though. Yeah. Okay. Part B. We are told I have a car with an actual. They've made it really obvious here by giving you the word actual. So the actual fuel consumption of a car is really 8.9 liters. I made a prediction that it will be 9.7 when the weight was 980. So I have a difference, right? I made a prediction, but then when I got a real car, the prediction was off. It was different. So we measure that difference or that error using the residual. Okay, remember, your prediction is rarely ever going to be perfect. So now that I've pointed that information out to you, which number is going to go where when we calculate the residual? All right, Anthony? Yep. Okay, it's the actual value here that's been given to you. When they give you a real data point, that's the actual value. And then the predicted value comes from using the equation that you get from the data. The residual value is negative. So that means that your prediction was larger than the actual value. Okay. All right, anyone still writing? Yeah. Yep, I'll give you another 15 seconds. So yeah, if you haven't noticed, it's not as bad as last lesson, but definitely a step up from the dot plots and box plots that we were doing a few weeks ago. Okay. All right, so we're nearly there. There's no example on the last page, so this is the last example. Okay. Ooh. No, I'm not going to improvise because that's when things fall apart. Okay, let's say I gave you some data. This is y, this is x. I'll have some points above and some points below. Now, can you see that these points are above the line and these points are below the line? Right? So these points here, are they going to have a positive or a negative residual? So it's actual minus predicted, so yes, it's going to be, oh no, sorry, this is the actual value. Actual minus predicted, so it is going to be positive, sorry. Yeah. So I'll actually color code it because I want to make a point. So I'll color the top ones green. And I'll color these ones orange. Okay, so when you graph a scatter plot and fit a linear model such as this blue line here, we can get something called the residual plots. So this time I'm not graphing y, I'm graphing the residual. So let's start with the green points. These points, the actual value is larger than the predicted value, so the residual is going to be positive. So it's going to look something like this. I'm just going to make it sort of random. Right, so the actual value is larger than the predicted value. And then I've got other points. Maybe I'll just make it a little bit different. Here, the actual value is smaller than the predicted value. So essentially what we're doing here is we're calculating the residual for every single point and we're graphing it to see what it looks like. Now, you don't have to do this, the CAS will do that for you. Okay? So once I've given you some time to work, I'll show you later how to get the residual plot on your CAS calculator. But here's the punchline, okay? All you need to know is we can only fit a straight line if the residual plot looks random. So you'll want to write this down. A linear model is only appropriate when the residual plot appears random or no clear pattern. This is a very common exam question. So they'll give you a residual plot and they'll ask you to comment on whether the linear graph that you modeled with was appropriate. So let's take a look at, this is question 11 now from the textbook. So see this residual plot here? Does that look random to you? There's a pattern. Okay, so it's not random, there's a clear pattern. All right, so should we fit a linear graph to this data? It's curved, so no, right? But also because the residual plot does not look random. Okay, so I'll say inappropriate. All right, what about the second one? Does that look, do you see a clear pattern to that one? I don't. It's hard when there's so few data points. So if I showed you this residual plot and asked you, is it okay to fit a linear model to this? What would you say? Yeah, it's okay. Okay. Random, no clear pattern. So it was appropriate to fit a linear model to this data. Okay, I don't really like the third question because there's too few data points. The textbook is trying to show you that there is a pattern. Do you see a pattern there? So the pattern apparently, as far as I can tell, is this. It's kind of like that. I don't see it either. Okay? So if you told me there's no clear pattern, I would mark you correct. But as far as I remember, when I check the answers, they think that there is a pattern here. Okay, maybe just check that for me, that I'm not hallucinating. So it's question 11. Curve pattern. Okay, so this is, okay. Um, can I just say something really quickly? If any of you do statistics in the real world, you would not fit a linear model to that. There's too few data points. You need more data. But anyway, um, Cambridge says, so I'll draw the curve for you. There is a pattern, and therefore it's inappropriate. Okay, this is a bit subjective, isn't it, right? So, um, my reassurance to you is that on the exam, it'll be more obvious than this. And on the SAC, I will not try to trick you like this. Okay, I'll give you one where it's really obvious whether there's a pattern or not. Okay. Okay, that's it. So the last thing that I want to talk about is writing a report. So you'll want to pay attention for this because of the following sentence that I'm writing. Last year's SAC was 40 marks. Okay, so I'm giving you a heads up. This is coming. Okay, it might not be 11 marks this year, but a big achievement of doing this course is that I can give you some raw data. You can chuck it into the CAS, you get all the statistics, but you don't just tell me the numbers, you tell me the story. So that means you're going to interpret the slope term, you're going to interpret the intercept term, you're going to describe the association in terms of strength, direction, and form. You're not just going to calculate r squared, the coefficient of determination, you're going to tell me what it means. So I'll put all this, I will upload this. You don't have to copy it down because there's a lot of words there. Also comment on the residual plot. So in exercise 3b, they give you the equation and then you do all this stuff. In exercise 3c, they just add one more step. They give you the raw data and you have to calculate the equation and then you do all the analysis. Okay? Sounds easy. This question was not answered well last year in the SAC. So you'll notice when you look at 3B in a moment that it's very long. There's like 18 questions. And that's because it actually takes a lot of practice to develop the skills to do all of this. So this is your goal this week. Because we're finishing chapter 3 today. Next week we're doing nonlinear stuff. So you've got study periods tomorrow. So I strongly suggest that you get chapter 3 under control and you learn to do this because, yes, I am putting one of these on the SEC. Okay. So I'm going to give you the raw data. I'm not going to give you all those prompts, by the way. I might just say write a report, refer to key statistics. So I won't tell you what you need to do. Okay, but I have told you what to do. Okay, it's right there. So Taylor, you had a question.
My question is just going to be, you give us the equation and you can give us the raw data.
So I'll give you raw data. So from raw data, you just have to enter it into your class and generate an A and B. Okay. So yeah, it'll take a while. Probably take a full period to do this question. Okay. The bad news is, I don't want to call it bad news, but it is kind of bad news. We're also going to do this with nonlinear data. So you're going to apply a transformation, and that's going to change it to linear data. So that's chapter 4. But chapter 4 is really the hardest chapter in this course as far as data goes. So do chapter 3 first, and then chapter 4 will be for the students, wanting high marks. Okay, so I think everyone's here. Yeah, everyone's here. So I'm looking all of you in the eye and I'm saying to all of you, I'm telling you what's on the set, right? You're going to write a report for me. We're using raw data. That's what you're aiming for in 4 weeks' time. Okay, so you can't come to me in week 10 and say, Mr. Chu, what is this 11 mark report that I have to write? I didn't know about it because you were here. Okay? So you'll want to refer to these 3 questions here. Question 16, they give you the report with boxes to fill in. Question 17, they just give you the information and you have to write the report yourself. Okay? All right. On that note, I think it's time for you to get ready for writing your report. So now's a good time to work on exercise 3B or continue working from where you're up to. Yes. Yes. So I'll upload this to Teams. I guess I can do it now. Yeah. Huh? Yes. And what's up, Jason?